Using ArcGIS Pro's default options, when views are created, whether they are maps, 3D local scenes, stereographic maps or base maps, the coordinate system assigned to them is that of the base maps they incorporate. This is the WGS 1984 Web Mercator system. However, this system is only maintained until the first layer is added to the view's content panel. When this happens, the view's coordinate system becomes that of that layer and remains so unless the operator changes it. If you have reconfigured the options that influence this behavior, namely the options that act at the application level found on the Map and Scene tab in the Base Map and Spatial Reference subgroups. If you want the views to be created without any base map, choose the None option in the Base Map subgroup. If you want the views to be created with a specific coordinate system, choose the Choose Spatial Reference option in the Spatial Reference subgroup and select the desired system from the available list. In this case, it will be very important to keep the Warn if transformation between geographic coordinate system is required to align data sources correctly box activated. Regardless of the options you may adopt, whenever the coordinate system of a view is defined, you can load layers with the same or a different coordinate system. In the first case, the layers will simply be loaded and directly visualized. In the second case, a transformation will take place to ensure that the layer data is visualized in the coordinate system of the view. Let's look at an example with the parishes from the Portuguese official administrative map. This layer is referenced in the Portugal TM06 ETRS89 system. If you configure the view's coordinate system in advance, with a different system, for example, the Hayford-Gauss system of datum 73, a message appears when you load the parishes, warning you that the coordinate systems of the layer and the view are different. In these cases, access the View properties. Select the Transformations tab and add an appropriate transformation or modify an existing one. In this case, there is already a previously defined transformation, which allows the projection between databases from the Portugal TM06 ETRS89 system, identified here as the Layer Coordinate System, to the Hayford-Gauss system of datum 73, identified as the View system. This transformation is configured to use the set of parameters called datum 73 to ETRS 1989-6, but as you can see, there are a large number of other sets. These sets are of two types: direct transformations between the two systems involved, as in the first four in the list, or composite transformations, which carry out two transformations using an intermediate system, as in the 7-parameter transformation between the Portugal TM06 ETRS89 system and the Hayford-Gauss system of datum 73, with an intermediate transformation by the WGS 1984 system. Regardless of these typologies, transformations can use various mathematical methods. As an example, in the first case, we have a transformation using the National Grid method, called National Transformations version 2, abbreviated to NTV2. This method uses a grid of points with known coordinates, and the data is transformed in such a way as to minimize the errors for the grid points that directly frame the area to be transformed, which makes it possible to obtain transformations with good accuracy. A different method is used for the second set. In this case, the transformation applies equally to all the data in the territory and involves translation in X, Y, and Z, with the values entered here, plus rotation around the X, Y, and Z axes, plus a scale adjustment. In all, this technique uses 7 parameters, 3 translations, 3 rotations, and 1 scale adjustment. In this other case, the transformation only includes translation in X, Y, and Z, with the values entered here, and is therefore called a 3-parameters projection. If you patiently analyze the rest of the sets, you'll see that they fit both the 2 typologies and the 3 transformation methods mentioned above. But with so many transformation sets available, which one should we choose? Is there one that is more accurate than the others? These questions have been debated for a long time, with advantages and disadvantages between the different options, so I would say that any of them could be used since they are all sets officially defined by the institutions responsible in the respective countries. However, from the point of view of accuracy, transformations using the NTV2 grid method generally produce better results. This is the case with the transformation initially selected, as you can see by consulting its details, which include an accuracy of 10 centimeters. But regardless of the choice, there is one fundamental rule to fulfill. In the same project, once you have chosen a particular transformation between 2 coordinate systems, you must always use that transformation. In other words, for any 2 defined coordinate systems, they cannot use a transformation in one view and a different transformation in another view of the same project. The same logic applies at the work organization level, so it is advisable to always use the same transformations, regardless of the project, and for all team members within the organization. If you ignore the warning messages, or they have been deactivated, and you don't define an appropriate transformation, the layers will probably be incorrectly visualized, compromising all the processes you might carry out on the data in those layers. In the transformations we have carried out so far, the visualized data is not affected in the slightest. In other words, the databases that physically exist on your computers will not be altered. The data was simply loaded into memory and transformed as it was visualized. At the end of your work, this transformation will be lost, and the next time you open the project the whole process will be repeated. In these cases, it is said to be an on-the-fly transformation, which could be interpreted as a real-time transformation. So that you realize this, I will load the database again, adopting the layer's coordinate system as the view's coordinate system. As you can see, the display is practically instantaneous. If we change the coordinate system of the view again, we realize that the display is much slower. This slowness is due to the calculations being carried out in the real-time transformation. As an alternative to real-time transformations, we can perform permanent transformations. In this case, the initial database remains unchanged and, as a result of the transformation, a new database is generated. ARC Toolbox tools are used for this type of transformation. The ARC Toolbox can be opened from the Analysis Tools ribbon. Or from the View Geoprocessing ribbon. Like the other windows, the ARC Toolbox can be positioned where you prefer. On the right, at the top, at the bottom, on the left, or superimposed on the content panel. In this case, you can switch between the Contents panel and the ARC Toolbox by selecting the desired panel. Returning to permanent transformations, the available tools can be found in the Data Management Tools box, and inside this, in the Projections and Transformations folder. Within this, the Raster folder contains tools for projecting raster model databases, which we'll come to later. The others apply to vector model databases, such as the parishes we've been using in this topic. The tool we will apply in this case is the Project tool. The database to be transformed can be defined from the Contents panel, if it is loaded there, or from any address, as in this case where we are pointing to the database stored on the disk. The respective coordinate system is recognized automatically. The database that will result from the transformation must be indicated in this other box, where the address must be defined. The name of the database that will be created as a result of the transformation. The coordinate system to which you want to transform. And finally, the set of transformation parameters that you want to apply. Finally, the transformation is ordered. And if all goes well, the transformed database will be loaded into the Contents panel. To finish, I recommend reading the page, Coordinate Systems, Map Projections and Transformations, in the ArcGIS Pro help. That's all for now. See you soon.